In this video we are going to explain the shifters. So on completion of this topic, students will be able to study what is bit slicing and what is booth recording. So shifters are most important element in many microprocessor designed for arithmetic shifting, logical shifting, and rotation functions, that is barrel shifter functions. So here the types of shifter are logical shifter, arithmetic shifter, barrel shifter, and funnel shifter. So first is binary shifter. So in the case of binary shifter, here you can see the diagram. Here this is very important for the combinational logic block. So here when we change some one digits to the other, that it can be rotated to the first slide, or it can be rotated to the left side, or it can be shifted to the right side. So in the case of the binary shifter, this contains right, top, and left. So first when you are changing the arithmetic that is when you are changing the binary shifter to the left, it changes the bit position, that is I minus 1, and if it is changes from the right side, changes to the b I plus 1, that is it changed to the right side. So in the case of the barrel shifter, so barrel shifter is nothing but it is very important part of the combinational logic block, and also it has the ability to shift data work in a single operation over standard shift left or right registers that utilize more than one clock cycle, and also it rotates number of clocks in a cycle such that empty spots can be filled with the bits shifted off the other side. So in the barrel shifter, if you are considering an example as 110110, that we are changing to the right side, means this first two digits should be changed to the right. So this becomes 10110. The one which is present in the first digit will be goes to the right side, that will be changes to the last digit, so it will be right to the 1. If it is changed to the left, means this first digits will be that is last digit will be changed to the first one. So this occurs in the left side as well as the right side. And here in this barrel shifter, this can be shifted data by a specific number of bits without the use of any sequential logic, that is only pure combinational logic. We can change the operation into the binary operation. It can be used to implement the binary operation such as logical shift left in the cases of limited amount, and the only way for this barrel shifter is to change the sequence of multipliers where the output of one multiplier is connected to the input of the next multiplier. And next one is the logarithmic shifter. So logarithmic shifter is based on the 3:1 Maxwell's, consists of 4 stages with the order of 1 bit, 2 bit, 4 bit, and 8 bit shift. So it can perform the following operations such as shift right logical, shift right arithmetic with the sign extension, shift left logical, and shift left arithmetic. And here this contains log 2 n stage, where the ith stage either shifts over 2 bits or leaves the data unchanged. So each stage of the logarithmic barrel shifter is controlled by a control bit, and the shifter is carried out by using this VLSI technology, and the functionality of this shifter includes arithmetic shifting, logic shifting, and rotation. Also it is divided into two smaller sections, which is easy to build and to test each function separately by each section. So here mainly this purpose of this logarithmic is to solve the exponential equation and to explore the properties of the exponential function. And so this will also become extremely valuable in calculus, where they will be used to calculate the slope of certain functions and the area beyond bounded by the certain curves. So why we are calling it as a logarithmic, means it is derived from the Greek word. Also this is the index, that is power of the tens, which equals the power. And the barrel shifter, so this barrel shifter is used in the hardware implementation of floating point arithmetic. So for this floating point add or separate operation, the significance of these two numbers must be aligned, which requires shifting the smaller number of the right, increasing its exponent until it matches the exponent of the larger number. So this can be done by subtracting the exponents and using the barrel shifter to shift the smaller number to the right by the difference in one cycles. And in the case of the logarithmic shifter, we have the pros and cons. It contains a transistor which is equal to 0 n log 2n, and cons is long interstage bias, especially for cyclic shifters. Target of the optimization, it is mainly used for the requires and shifting the smaller numbers to the right by increasing its component. And the cyclic shifter, so normally the cyclic shifter changes according to based on the cycle. It changes in the finite field arithmetic, that is in the normal bias. In this, squaring can be done by cyclic shifting, and encryption is by shifting the rows in the Richardson algorithm, and DCT processor unit is by address register. Bidirectional shifting can be implemented as a cyclic shifter with the additional masking logic. So here we used a Cordic algorithm. And the gate complexity is, there is no extra complexity at the gate level, but it has the two types. One is mux based and it is demux based. So here this durability is providing the flexibility at the lower level implementation. It is only good for static CMOS in case of NAND gates, and good for dynamic gates in the case of NOR gates. Quiz questions: give the difference between Booth recording and modified Booth recording. Thank you.